Welcome to today's explainer. Look, if you've been paying attention to software development lately, you know the game has completely changed. We're moving way beyond those basic, honestly kind of flimsy ChatGPT wrappers. Today, we're going on a builder's journey to demystify the rapidly evolving landscape of AI agents. We'll break down exactly how you can build these autonomous reasoning systems yourself, because mastering this architecture, it's pretty much the single most valuable skill you can have as a developer right now.
Okay, here's our game plan for today. Think of this as our cognitive map. We're covering 1. Beyond chat, the agentic loop. 2. The React architecture pattern. 3. Scaling with multi-agent systems. 4. Choosing the right framework. 5. Solving the memory problem. And finally, 6. Deploying agents to production. Let's jump right in.
Section 1. Beyond chat, the agentic loop. We are kicking things off with a massive paradigm shift in how we think about AI software development in 2026.
So, to really reset our mental models here, let's establish the core difference. While standard chatbots just respond, true AI agents actually take action on the world around them. Think about it. A chatbot is static, right? You ask it a question and it simply predicts the next best word based on its historical training data. No agency whatsoever. But an AI agent? You can give it a vague, high-level goal, and it will autonomously break it down into a multi-step plan, write its own code, execute that code, search the live web for missing context, and, this is the real game changer, correct itself when it makes a mistake along the way. It's literally a system working on your behalf.
And the engine driving all that autonomy? That's the agentic loop. It's basically this continuous cycle where the AI observes its current state, reasons about the task at hand, calls external tools to take action, reflects on the results, and then repeats the whole thing until the goal is met. It observes, it thinks, it reaches out to a database, or actually any API really, evaluates what it gets back, and keeps iterating. This is absolutely crucial because it shifts the entire burden of execution from you, the human prompt engineer, directly onto the AI itself. This loop is basically the heartbeat of every modern agent.
All right, moving right along to Section 2, the React architecture pattern. Let's dig into the exact mechanism that makes this agentic loop possible.
The React, or Reasoning and Acting architecture, has become the absolute gold standard in the industry. It breaks down into 3 highly deterministic, step-by-step actions: thought, action, and observation. It completely forces the language model to work methodically. It has to clearly separate its internal thinking from its external actions, and by doing this, it creates a super traceable reasoning chain that we, as developers, can actually inspect, debug, and trust. If your agent fails a task, you can see exactly where it tripped up. Was it the thought, the tool execution, or the observation?
Let me give you a perfect example, taken straight from the daily dose of data science. Look at how the AI talks to itself internally. Instead of just guessing what 1, 2, 3 plus 4, 5, 6 is and risking some weird hallucinated math error, the model explicitly writes down its thought, calls a calculator tool, and observes the factual result. This is exactly how we stop AI from confidently giving us totally wrong info in mission-critical applications. It takes the AI from being a creative guesser to a rigorous, dependable executor.
Section 3. Scaling. Multi-agent systems. Because, single agents are great for focused tasks, but what happens when we need to scale horizontally for complex, enterprise-level workflows? I mean, you wouldn't ask one person to be the researcher, the writer, the editor, and the publisher all at the same time, right? The exact same logic applies to AI. There are 3 main multi-agent patterns here, and picking the right one is vital. First, the orchestrator-worker pattern. This is perfect for things like financial risk assessment, where different workers simultaneously analyze credit risk and market conditions in parallel. Second, we have hierarchical teams, which use a supervisor node to route complex state graphs. And third, collaborative workflows that chain tasks sequentially. Choosing the right architecture can boost your performance by 81% on parallel tasks. But, and this is a big warning, if you force, say, a sequential process into a parallel architecture, your system's reliability will absolutely plummet by up to 70%.
Okay, Section 4, choosing the right framework. With the architectural theory out of the way, let's talk about the practical tools you can use to actually build these systems today.
You might want to take a screenshot of this one. It's a highly pragmatic decision tree distilled straight from the developer community to help you cut through all the marketing hype. Building a complex, stateful production workflow with approvals, LangGraph is your powerhouse. Just need to spin up a fast, role-based prototype to prove a concept? Crew AI is fantastic for that. If you're building a product natively in TypeScript or Next.js, definitely look at Mastra.
For heavy document retrieval, Llama Index is your best bet. And for long-term memory assistance, Letta is the way to go. The main takeaway here, never try to force a framework to do something it just wasn't natively built to do.
Section 5, solving the memory problem. Because as you build more complex agents, you're going to hit a wall real fast.
Yeah, the hardest technical hurdle in AI right now is managing context limits and long-term coherence. Standard language models just forget things as the conversation drags on. To fix this, recent academic research is proposing solutions like Memory OS. Think of it kind of like how your computer manages RAM versus a hard drive. It's a unified operating system that overcomes fixed context windows by dynamically moving data around in a sophisticated hierarchical storage architecture. It prioritizes what's immediately relevant while archiving what it needs for the long haul.
Let's break down how that flows in practice. Information comes in through real-time short-term memory during a live chat. Then it gets actively processed and grouped by recurring topics in mid-term memory. And finally, it updates persistent long-term memory using this really clever algorithmic heat score. So if you and the agent talk about a specific topic a lot, it gains heat. Once it hits a certain threshold, boom, it gets permanently etched into the agent's persona and knowledge base. This means you get deeply personalized, coherent experiences that actually persist and evolve over months or even years of interaction.
Section 6, deploying agents to production. We've covered the architecture, the frameworks, and the memory systems. Now let's talk about surviving in the real world.
Building a cool little toy agent on your laptop is fun, but deploying it to live enterprise users, that's an entirely different beast. Get this, over 73% of enterprises are actively investing in agentic agent systems right now. This isn't some far-off sci-fi future. This is a massive, accelerating arms race happening today. The stakes for getting this right are incredibly high. So, to make sure your deployment doesn't turn into a nightmare, you need to act like a seasoned senior engineer and set up some strict guardrails. First up, infinite loops. You absolutely must set a maximum iteration limit so a confused agent doesn't get stuck in a loop and burn through hundreds of dollars of API credits in minutes. Second, context overflow. You handle that with smart background summarization. Third, cost overruns. Use tools like semantic caching. This can literally cut your costs by up to 90%. And finally, unpredictable execution. Look, if your agent is doing sensitive things like sending emails or executing financial trades, always put a human-in-the-loop approval step in there so a rogue agent doesn't cause a total disaster. The shift from reactive text generators to autonomous reasoning agents is hands down the most exciting transition in software today. It is totally redefining what applications can do for us. So before you write your next line of code, ask yourself this. The future of software is agentic. Are you building an agent or just another chatbot? Thanks so much for joining this explainer, and we'll catch you next time.